Okay, before the break, we looked at abstract classes and interfaces, which can be very useful things, and generics, um, sort of ways that they give us wiggle room in that strictly typed nature of Java. Just when, at the initial creation of the text file that will eventually become an application, we don't know every single detail. Some of them won't be filled in until later, so we need to have the placeholders to fill in later. There are a couple very common interfaces that we might want to use. So I'm going to look at a couple common interfaces. Yeah, so we made our own interface. As soon as Zoom gets all the buttons out of the way, I'm going to close a bunch of these. Leave animal open, zoo, what's that, and that. Okay, that. So we can implement more than one interface. When we might want to I'll put a comma and then serializable. Can't find it, so push Control-Shift-I to import it. We get java.io as an in-out .serializable. This is one built into the language. Serialize. Everybody's heard like serial communication, right? Or USB, Universal Serial Bus. Let me draw a picture, make sure these words are clear. The serial, all the data comes in a line. Why is that underlined again? Oh, whoops. I didn't mean to accidentally delete something there. But like serial communication is all of our bits would be flowing down one wire. We usually write it like this, but it's kind of like a light switch. Right? It's either on or off. That switch is on or off, and then there's power the whole way between the switch and the light. But if we're diagramming it, we put it like this versus parallel, where we have a bunch of wires, and we'll send each bit down its own wire so that we can transfer more at once. This is usually used internal to machines because it's really easy to like build this into the printed circuit board that all the motherboard parts attached to. But if we're plugging up something external, it's a lot easier to plug up one wire than modern machines are mostly 64 bits. So we would have 64 different wires to connect. But that's where the serial part comes in for like that single row, because oftentimes our applications are going to be multi-threaded and running on parallel processors. So we'll have our software split up between different threads on all the different cores of our processor, which we'll see how to do by the end of the semester. So if we want to write it to a file, we probably need to turn that into like serial communication, where it's all in one place and a nice flowing in a nice orderly row. That's what serialize is. This is necessary to write to a file. I'll just add a comment in here. Serializable is necessary to write to a file. I've mentioned Java Beans. We're going to talk about those before too long. They're not far away in detail, but that's one of the things is it implements the serializable interface, which means it can be saved to a file. And there's nothing in that interface either. That interface looks like this. That's yeah. Public interface, serializable, open curly brace, closing curly brace. There's nothing in there. It is just a requirement. There's not any of those rules. Call it the method headers that we treat like rules. The requirements we set there in order to do stuff that's just empty, but we have to have this in order to write files. All the stuff that writes files looks for this, and if we don't have serializable on that class, it says nope, can't write it to a file. So it's just a confirmation thing. So that's a common one that you're going to want to use as part of beans. So use that all the time. Serializable is required in beans. There's two other ones. Comparable, that's the one we're going to look at tonight. Comparable Java. Let's go look at the official documentation for this. So this interface comparable, notice the generics. So it's not just methods, we can put those in classes as well. So a comparable interface, how much stuff there, what it does, it imposes total ordering on the objects. Sounds strange, right? It gives us an order. It requires us to implement this method compare to, and then something else of the same type. So we're doing animals, so we'll be able to compare to another animal object. And compare to, notice returns an integer. That's what greater than, less than, or equal really gives us. You're used to those comparisons, right? Everybody's seen enough programming to know greater than, less than, or equal, the ones we do most often. All we do for those is subtract. We take two numbers and subtract them. And if we end up with a positive number, then the first number was bigger. If we get a negative number, the second number was bigger. And if we end up with zero, then that means they were the same thing. So that's how we get greater, less than, or equal. Subtracting, and we should have some sort of integer like that. Subtracting the binary representation. So it doesn't necessarily have to be integers that we subtract. If we have whatever we have is going to be represented as a binary number, so we just subtract those binary numbers and see if the result is positive, negative, or different. But we're required to implement this method. That's what that interface does. And it allows us to compare stuff. So that's one we use a lot. There's also comparator. We will see this one later in the semester, which is very similar. Only you'll notice there's a whole lot more things to it. At this point, we just want the comparable. So we'll also implement the comparable interface. Comparable requires us to implement the compare to method. Compare less or as ints. So remember those documentations, check those. Oh, that's where that word ended up. I'm gonna take out the word abstract here so they get this error message. And notice have implement all abstract methods. I'm gonna undo the noisy one in a second, but if I click that, then we get that make sound method. So I'm gonna take that one back out, but it also overrides that compare to. But you'll also notice that we don't have anything that has we don't have any, we didn't get anything from the serializable interface. It doesn't have anything. Other stuff will look for that interface just to confirm it's there. So we have to have it to write. I'm going to get rid of the make sound method, which means I have to put the word abstract back up here. And work with this one. So notice by default, it just said it's an object. But on the document, the official documents we were just looking at, Notice that it was created with generics. So we don't have to go to that object because that's the like top level class that everything else from it inherits from. So that's the one we know we always have those methods. But we can be more specific. We know we're dealing with animals, so we can fill in that placeholder there. So it would compare to also works with animal objects. That's that means not like that. Okay, I'm gonna go back and to just what works, and I'll just use casting like we did up on the thing earlier. We don't know when to use interfaces. We can check the interface. I'm just gonna go back to this object, and earlier we did this casting because we knew we had an animal object. But we don't want to, might not know for sure what we have. What's a good way to compare to? I guess the weight again, right? We can do like we did earlier. We can compare our animals on bigger and smaller. So first thing we need is we need to make sure we have an animal object. Or anything animal is going to have, anything that will work with animal would have the noisy interface. So we could just cast it to that. Noisy animal equals cast as noisy. I'm change that O to OBJ because it's not necessarily, it's O is not a good variable by itself. Same reason we don't use O in math class. That's not let me do that. It didn't have any problem. I know it's going to work, but there's no guarantee that it's going to work. So usually we want to do something like try and catch. So try to do this. And if we can't do that, it's some sort of exception. And we'll get to the try catch block soon, kind of previewing it. I believe it shows up in the 140 class, right? Everybody see try the exception handling. We're going to talk more at length. One thing, your textbook and pretty much any tutorial you see, when they do try catch blocks, they're going to have you print out a message, stop the run of the program, and print out a message. But what happens if we don't handle the error? It stops running and prints out a message, right? So to stop running the program and print out a message is not handling the exception. I'm gonna make a big deal out of that soon. Previewing this now, it is not uncommon for your catch block to have more code that will hopefully never run than the actual code in the try block. Because what you want to do is fix the problem. It's not to stop running and throw out a message because that's what happens if you don't address the problem. If you hit a problem and don't fix it, the app stops running and spits out a message. So just printing out a message there is the exact same thing. Make a big deal out of that soon. So if we don't do that, then I'm just going to go ahead and return a negative number. So notice it's an integer. And we'll use that when we compare things. So if we get a positive number, we'll say the first object is bigger. Right? We'll have animal dot compare to other animal. So if the first object is bigger, then we have a positive number. If the second object is bigger, we'll have a negative number. So actually, I want to return a positive number here. I'll return positive number, maybe positive one. I'll return -1, 0, or 1. It can be any difference of the numbers. But I'm just returning a positive number to say our object is bigger. If the other thing's not an animal, ours is bigger. And notice how I just cast that into an interface, not into a class. That's something significantly different. When you take, if you take the mobile app development course, either iOS or Android, you will do a lot of that. There will be a lot of using interfaces to see if what you have will work. And we just, all we do is cast it, instead of casting the object into another class, we cast it into an interface that the other class has. Kind of like the plugs. That's why I like the plug analogy. We just, before we plug it into the computer, we make sure we have a USB port. And then we know it will work. What's another one? I bought a few MIDI instruments lately. And the one requirement when I'm shopping for new ones is I make sure they have USB ports, not the old 9-pin MIDI ports, because I run everything through the MacBook. So even if it has that, I still run it through the Mac before connecting to the other machine. So any new MIDI equipment, I just confirm that it has the right interface on it. And then we can subtract those, right? So this dot get weight minus animal dot get weight. We'll declare that we have that animal, and then we'll try to turn something into that. Then we'll try to make sure it has the interface. If not, we'll just return a positive number. Oh, and noisy doesn't have get weight, does it? Let's make a new interface that does have get weight. Or I could put it in noisy. I'll just add it here. We're required to have a public double called get weight. Within our interface, those are our requirements. In order to compare things, a noisy animal has to have a weight so we can compare it to other animals, and has to make a sound so that we can print out the sound. It'll make more sense when it's not a completely generic, overly simplified classroom example. Like when you get to your final projects, the things you put in your interface will make way more sense than those. But notice now we have those requirements. This one gives a warning, so it's saying it would be better. It's yellow, not red. It'll run without it, but it's saying it would be better if we add that annotation. So I'll go ahead and click that and add the annotation in there. Oh, gotta be in it. This double difference equals that, and then if difference is greater than 0, I did that again. I did that the other day too, didn't I? Let me try that in Java syntax instead of Python. If difference is greater than 0, inside of parentheses with curly braces, then we will return a positive number. Otherwise, if difference is less than 0, we'll return a negative number, or just -1. And if it's neither one of those, then we'll return a 0. If it's not greater than 0 or less than 0, it's got to be, there's only one option left. You see how we can compare our differences this way. parsing conversion from double to int, but sure. Those are all doubles now, right? Double get weight, yeah. I don't know why the error message isn't going away here. Because that's a double, that's a double, that's a double. Put anything to it. Flip operands of the binary operator. Let me ignore that. I think that's just the IDE glitching out because those are all doubles. I don't know why it's telling me it can't convert it to an int. It shouldn't be trying to convert it to an int, but then we can do some comparisons. So if Fluffy compare to Nemo, and then we can just say greater than 0, then print out the cat could eat the fish. Else if not available, Fluffy compared to Nemo is less than 0, which would mean the fish is bigger. Fix a typo. So Fluffy compare to Nemo. So the first object smaller than the second object will give us a negative number. And we'll bring out the fish could eat the cat. But I guess hopefully the general points there we can see the cat's bigger than the fish, right? So we get that option, or if we make that a much bigger fish, set weight instead of 0.5, it's like something the size of a tuna, 220 pounds. If you wonder where tunas are about the same size as humans. Large tunas are the size of large humans. So definitely a fish large enough to eat a cat, unless it's already been just sold in a very, very small portion, like we're used to seeing tuna. The idea of the comparator makes sense, or comparable. And then that's something we could check too. Same way if we move that down to a method, public void who eats who. Well, we don't know exactly what's going to be passed in, so we need those generic types again. So some sort of type, whatever it is, we need to make sure it extends comparable. As long as it has that comparable interface. Extends comparable. Use an ampersand or a comma here. And let's see. That might be the wrong syntax. I'll adjust it. It might be a comma here, but I think we use an ampersand. If it's comparable and noisy, then it's definitely an animal, right? We're setting up, Gabriel used that term earlier. We're setting up the structure of it. That's something we know about animals, so then we'll pass in a couple of types. P, I'll just call it first and P second. And then cut that and move it down to this method. And then we have first compared to second. And we don't have to worry about whether it's going to work. That error message, I know you all have all seen many, many times in Python. And, after the number of years that I've been using Python, I've been the lagging teams somewhere now. I can tell you, you will keep seeing that for as long as you use Python. It's really easy to try to print an int or concatenate. Right? Everybody's saying that. Try to print an integer or a float, and Python will tell you you can't concatenate an integer with a string. This protects against that. Right? We restricted it. We don't know what type it is. We can pass in any type. It's almost like it's open right here. Almost like it's dynamically typed, except that we did restrict it, so that has to be something comparable and noisy, which would be our animal objects. So we know this would work. And we probably want to print this in out. So plus first. And might be the fish, but if we say plus second, as soon as we concatenate it, it will call that toString method. You know, I remember a few minutes ago, we adjusted the toString method so it spits out the name of whatever class it is. Spits out fish or cat. Here plus second could eat the plus first. And now, hopefully everybody's aware that's much better form, right? So if we do zoo.ui2 with Fishy, I forgot Fishy was in there. Fluffy and Nemo. See that the fish could eat the cat. I forgot there was two fish in there. If we compare it to the other fish, Fluffy and Fishy, which is probably goldfish size. Yeah, see the cat could eat the fish. So it gives us a way, that's how we set up the comparisons to use in our if else structures and generics and a whole bunch of stuff here coming in. What else did I have on the list to show today? So abstract classes, interfaces, generics, comparable and serializable, the thing from documentation, git commits. Actually, this was going a lot quicker than I thought. I thought it was going to be a late night, but it looks like we'll have plenty of time to practice this. I'll have it up on GitHub in a few minutes, and we really go pick up if you all right. The video will be ready right afterwards. So this will be incredibly useful for your restaurant.
Okay.
So you'll want to watch the video. You can find timestamps. We came back from break at 7:25, so 30 minutes into the second video.
Okay.
So there's other things we could work in about animals, right? The fish, cat, dog. Probably add a bird here. Let's add a bird. Let's add a couple more critters. Click new color class. Let's make a bird. Finish that. This out, this out. Bird again is going to extend animal, which has all those interfaces in there. So we have some restrictions here. Bird is not abstract and does not override the make sound. So we'll implement any that we have left to do. What's the bird say? Return bird. Birds really like just a single chart. There's some small ones that do, but usually there's a song going on. So our bird object, don't necessarily need a whole lot of it with that. But there's some another thing that we could talk about with all these animals that we haven't really addressed Now the birds in here, we can kind of see it. So birds would have feathers, right? Um, the lion, the cat, and the dog, those would have hair. Fish has scales. So there's different um, different types of coverings they could have. But there's a finite list, right? It's a short list of types of coverings that the animals are going to have. It's not as open as other things. So short list, whenever we have a short list, we could just type it in, but sometimes what we call it a short list is technically just a finite list. Like if we started listing out named colors, there are what, like 800 named colors. So that's not a short list we would want to take directly into our code. We probably want to try to keep track of all the hexadecimal colors that we have the names of. So it'd be nice to have the words there. Or anytime we have a short list, or really should say finite list, a good way to set up that list is to create an enum. For those who have had the data analytics class, I'm sure it's not familiar, right? One of our concepts was enums, the short list to choose from. Sort of what we would put in a drop-down menu. There's only so many options to choose from. You can't just type freely into a text field. You choose one of 5 options. It's short for enumeration. In C++ and in C sharp, it does actually count as a number. When you write out your list, the first one you put there is a 0, the second one is a 1, the third one is a 2, and you can do numerical things. But that's not the case in Java, but C++ is still in there, and in C sharp they did add that. So some languages we actually get a number from an enum, which stands for short for enumeration. I'm like an enum called covering. And really all we need here is a short list. And we just type the list of options. So we have some things could have scaly, scales, feathers, hair. Do we need any other? Yeah, I get that. Slime. Some things are going to be coated in slime, especially sea creatures. But a few land things, we'll use the word slime. I guess there's more technically correct terms for it, but like eels and snails and shells. Those things are going to have shells. We don't necessarily have any, but there's a short list of things our animals would be covered in. So we can notice it's in the same package. We haven't done anything outside the package yet. In our example next week, we're going to reach outside of our package, and we'll see how to deal with that. Usually we do it with the import statement, but there's a much messier way we can do it directly in our code. We'll see on the plan for next week. So we can set up what sort of things these animals all have. I guess that's an overriding property, so we'll probably put it back here in the parent animal as one of our data fields. So another private data field. Oh, I didn't notice she disappeared from me. So we'll set up another private data field for that enum. It's covering type of data. So just like we saw with the interface, it is a data type we can use. We'll just refer to it just like our other data types. That's yeah. I'm gonna use the word covering for this one. What would be a good word for that? What's the surface? Yeah, I'll use skin. Whatever skin is out. That's probably not the best term. But we'll add that in there. Well, animals abstract still, so we can't make any animals. We don't really have to worry about it here. But in our other ones, I do want to put stuff that apply that to things. Oops. So like in the bird, which we never made any constructors for, I'll insert, bring in all those constructors. Yes, select all of them. And all of these constructors, they need to do whatever the super one did. Call the super constructor. And then also set the covering, which notice if I do this dot, it's not letting me access covering from here. So I'm gonna come back over to that animal, the parent one. And here in animal, instead of making this private, I'm going to use the word protected this time. So protected is still private to anything really outside of us. The difference is the child classes will inherit it. So you think of using parent-child terminology, it works nicely there. Private is the parent stuff, and protected is the family stuff. So the child still has access to it. Like our houses are private things, but kids get keys to the parents' house. We have a way to unlock the front door, even though it's the parents' private thing. More like taking that terminology a little further, it's like the family stuff instead of the strictly for the parent. Now I can access that directly. Oh yeah, I called it scan. So it's protected, so this child class did inherit that data field. Otherwise, the parent keeps the data fields and we have methods that can reach back up and access them. The child inherits the behavior, but not the actual data field, not the property. But if we make it protected, then the child inherits the actual property itself. So this .skin is one of our coverings, and our syntax for that, which you've actually probably seen already, is the name of the enum covering dot something here. Oh, I broke with dimensions. Sorry, I got distracted for a second. I'm not sure what I was thinking. Let me change this. These are constants, right? In Java, our constants should be in all uppercase letters. So there's the option for the verb would be covering dot feathers. And we should get it from the list. Yeah. And we can set it up that way. At this point, it probably doesn't look super useful, but it is. It is incredibly useful. What's the number one? We're gonna need to be called super dot. Oh wait. I'm not sure why that's not coming through. I'm gonna go back to a different syntax, sorry. I don't know why that didn't work, so I'm just gonna make private and set the covering and then add getters and setters for it. That's probably quicker. So somewhere down here, I'll put it around all the getters and setters in the code. I'll insert getters and setters, and there's only one new thing we've added since then. generate that, and you can see we have that in, so I'll just use the setter instead of doing that here, so. Set covering. Which we do have this dot set covering, that'll work, and we can do covering dot feathers. Why is it still telling me I have an error? Oh. Sorry, I've been staring at the screen for too long. That should be set scan. You might notice that I just used the completely wrong word there. And confused myself way more than I should have. But sorry, if I type the right word, we can say this dot set scan because we inherit that method from the parents. And I will look into why that protected thing wasn't inheriting. I'm not sure why it didn't work. It showed up on the predictive text once so that it worked, and then it quit working. And I have no idea why it quit working. And then I'll just copy and paste this into all the constructors. And same thing for all the other ones. Bird, cat, super constructor, and then we'll set the covering to hair. I guess that should be fur. Copy that and just paste that into all the constructors. We should be giving me a warning. Is it giving the warning? Okay, yeah. It doesn't like when we do this. This isn't the best form. It would have been much better to use the protected method, but I don't know why it didn't do that. We shouldn't do things in the constructor unless we're, and if they can be modified afterwards. Um, Ignore that warning doing it this way, and we'll enter, and we'll come back and do the other thing soon. So that gets us skin on the cat and the bird. Yes, save changes. Thing we need to call the superclass when we do the constructor. It has hair, so we just copy and paste this into all the constructors. And ignore the warning that it gives it. Put that. Interface, we got too many files up here. I thought it had been said, maybe that's why it was, it didn't like it. Go to fish. Fish has scales. I'll hit the N key and then shift and home to highlight the line. That's a great way to do that. Paste this in, this, this, that's all the constructors. What's that? Okay. And line tab. Here. See how this would have been much quicker if we would have done it at the beginning. So it's kind of like that code generation thing. You want to think about things. It is worth your time to think about things ahead of time. Usually coming in this class, the 200 level class, people have been writing programs that they just sit down and just start typing and it comes out great. But a little bit of forethought goes a long ways. So we're getting to a point now where we want to think a little bit ahead about what you're doing. This one stretched out nicely because we just introduced what enums were a moment ago. But it gives us a short list that we can check now because it's a definitive thing. It either has scales or has hair, or I copy and pasted the wrong thing. I did. Lions don't have scales. Save that. I think that's all our animals. And notice the syntax should look very similar. We have the package names first thing in the file. Publicly accessible, and then instead of a public class, it's public enum, which just means short list. We can put small methods here, so we could do something like public int. What is it? Or something like that. We can put a method here and then return a number or something. What I'm going to do is use this in a selection structure. So I'm going to come back over here and check a few things. Let's do another method with generics. So public something, don't know what type it is. Probably print stuff off, so I'll just make it a void. We don't need to return back to the collars. An output is not a return. That goes to the human, not back to software. Coded it. What's coding it? Something like that. And we'll pass in those keys. I'm going to do the short syntax. Really, we should probably do the same thing we did here, because that's how we confirm we have an animal, right? If it's comparable and noisy, then we don't have an animal. I'm just going to leave it as the generic type, because for your final project and practice work right now, you'll probably do this a lot more often. Just put a generic there, and then you know what you're going to pass in there, so you don't need to. Not like you're on a software development team with 500 people, and the person that's going to use this method is never going to talk to you. And so you don't need to implement those things now. For your own stuff, you'll probably look like this, but then we can just do a switch statement on it. Switch on that T dot. Well, T doesn't have any methods we can call. We could cast it into an animal to make sure, or we could add that to our interface. I'll add that to our interface. If we require that we have a public or public covering of get covering. But I said we would do this, but I'm gonna go ahead and do this so that we can just use the interface, because this is better form and this is what you want to build to. Most of your examples right now are going to look like this. And then as it starts to make more sense, you'll build up to something like this. Now we know we have an animal, so we can say T dot get covering, because that interface requires that we have this generic type has to have that method included in it. Sorry about suddenly changing plans and all, but when you practice, most of your stuff gonna look like this. But since we're talking about interfaces this evening, I'm gonna go ahead and put this in there. You want to build up to those extra restrictions on your generic type. So it's not just any old placeholder. It is, there are some restrictions to it. That word that was used earlier this evening, there is some structure to that placeholder. And then we only have there's a finite number of cases, right? So those enums go really nicely into switch cases, because one of our cases, we could have the case of covering dot the ones that are here. Could be scale, feathers, hair, slime, or shell. So it could be scales. Then I'll come back and type the rest of that later. I like to type it this way. I always do the cases first and then come back and put it in each case. Could also be covering dot, why is there no predictor text? case. Covering. Oh, okay, sorry, we don't need covering. We can only put. We can only put coverings in our switch case. So we can, sorry. In some of our other C family of languages, we have to type the name still. In Java, we just need that. So it could be scales, could be hair, could be feathers, could be there, slime or shell. Slime, or it could be a shell. Or we could have a default case and print out no idea what it is. If it's not one of the coverings we know about, I have no idea what it is. Otherwise, as out, that sure is a scaly thing. Break out of our switch case. If we have hair, this thing is shedding everywhere. And then break out our switch case. Feathers are usually really colorful. A good segment for feathers. Oh, there's something about feathers. We've already hit the key points of this example. This thing sure is slippery. We didn't put any slime on anything, so that's not really short. Anything but. I guess I shouldn't have had to thought that hard about it. Should have quickly realized that we didn't put a shell on any of our animals, but that was just an extent. So that's where we would use our short list and set up those enums to check, because it has to be one of those things. And using all those examples that we used this evening is definitely going to take some practice, take some getting used to. Basically, that's what you have to do for your object-oriented stuff for your classes. And we're going to set up some abstract classes or interfaces. You're probably going to have some enums because they're going to be very useful for all the project ideas I've seen so far. All the ones I've seen so far, you'll definitely have a short list of things to choose from. The enums will go in there. Generics are a requirement, and we're working in Java, so object oriented is definitely a requirement. So tonight's class covered a whole lot of what's in there. And then I guess we can call that out a couple animals here at the bottom. So like zoo, what's coding it? With and the dog is Buddy. Oops. I can type in the right spot. Zoo dot what's coding it? And we'll pass in one of those, Nemo, that giant fish. Zoo dot what's coding it? And whoops. I can pick the right thing out here. Simba, the lion. Those are errors. I did that again. That's like I made that mistake this evening and nobody called me out on it. I called it skin. The method should be get skin and it returns a covering. I put get covering. So then over here, that switch case should probably be looking at t.get skin. Okay, sorry about that. Maybe I should have
Oh,
just
I
called.
thought you corrected that.
What's that?
Said I thought you corrected that one. Was it in more than one?
I did. I made the same mistake twice.
Ah, okay.
Yeah, I guess I could have discovered it because I corrected it once, but then when we came back over here and did this, I put get covering again, or something that, yeah. The
It's
next
late.
time I asked for it, I did the same. I made the same mistake twice. I should have just called it that to begin with. No pointer exception. Critters dot covering dot ordinal. Why does it not like that? We've been at this for a while. I'm going to simplify this. I'm going to take all of this and do a simpler version. Oops. I'm not sure where the typo is, so I will look for the typo later. And make another method with the same name. Public generic type was covering it. Takes in that generic type. And if e dot get skin, oh, we need to cast it, don't we? Animal thing is cast T into an animal. Over. That way I can do both multiple syntaxes in one thing. So now that we have an animal, we can say get skin. If thing dot get skin equals covering dot feathers. Which sends to the right up here. Whoops. Else. Copy that. If it's hair, and this sentence. I'm just abbreviating this to the part we need, and I will check for the error message after class because we've all been staring at the screen for 2.5 hours now, right? I think that's why I'm not seeing that error. So I will check for that after I've given my eyes a rest, and we'll fix that. Whatever we'll add in the part that I left off in that previous method after class. This needs to be void. That's wrong. Need that whole else everything. Copy that. Paste that there, and what else do we have? We have stuff with, yes. Those are the only three we had, we don't need that whole. We don't need all the options anyway, there we go. That way we'll get some sort of output from it. Does everybody see what I did there? Logically, it's basically the same, just using an if else instead of the switch case. But I apparently made a typo. I'm thinking that's probably just because it's been we've covered a lot this evening. This is probably a better example too, because remember I said this is what you all do when you're doing your generics. The other part is a little bit confusing. It might make sense when I was talking about it, when you go start making your own interfaces and working those into those restrictions in, that takes a good bit of practice. So for starting with, you'll just do all your generics this way. Now I think it'll work. Did I give it the wrong name? Okay. I think I made a typo in the name, so I just copied and pasted it from the other place. That way it looks right. And it will run, and then that kind of finishes up the list of stuff for this evening, which I think that most recent example, or there at the end there, that was from trying to shove too much in once. So after my eyes have had a break, I will fix that error, and then we will quickly look at the correct whatever I left out there to start the night on Tuesday. Probably put this on GitHub, so there's all those changes. Let's save those changes or commit those changes, right? We're satisfied with the latest version of the software. Or we want to make sure everything's saved. And whenever you run it, it will hit save on all the files. So obviously they have to be saved before we compile them. So that's a good thing a good way to check to make sure everything's saved before you close out the files. Git commit -m. With enums, just some message so we can see which version is which. So now all of that's there. So let's say git remote origin. We can see it's still connected to the GitHub version. So let's say git push origin main, and now it's back up on GitHub, so you can refer to that example there this evening. But a whole lot of stuff tonight. So we started looking at a little bit of version control. We're not going to dig into that very deeply in this class. I wanted to look at something more than using GitHub as online storage, because in that case we could just use Google Drive if we just need online storage. We're going to see some of the functionality from that. Get a good look at GitHub. At some point, we might also 200 should be a couple of them. This one is us. At some point, when we're here and look at some of the project management tools, or if you all are interested, you can look at project management tools. We'll probably talk about those in class sometime soon because you have a project coming, but they're more for team things. I think that was everything I had on the list. Yep. That was a lot of stuff tonight, right? Does anybody have any questions? Because that is also new stuff. Up to this point, it should have all been reviewed, but I don't really expect anybody to have seen interfaces or abstraction before this class is where we introduce those. And enums. So a whole bunch of new stuff. We looked at a little bit of version control. Hopefully it's not overwhelming. That example is on GitHub. The recording will be up in a few minutes. It usually takes Zoom about 20 minutes to process that, and then it'll be available on iLearn. Usually Saturday morning is when I move the videos over to YouTube, make regular controls. But you'll have already seen the lecture, so at that point you can watch it at double speed or something and just jump around and see the example if you need to reference back to it. Because now we're into new stuff, and it will be new stuff all semester long. Oh, there's something in the chat room. Oh, okay. Yeah, I figured something that happened. Also, I usually use my personal laptop, so if you want to send me a direct message, it's best to use the one that says Chris is me. So like tonight I'm on the PC, so Chris PC.
Got it. We'll do that in the future.
Yeah, I just use that computer for the really good camera and microphone they have in the classroom. I like my computer where I have permission to do stuff. Schools like to lock down computers. So the one that it'll say Chris PC or Chris Mac or Chris TV if I'm on the Chromebook. But it's obvious. It should be obvious which laptop I'm on. I think I asked if anybody had any questions, right? A couple seconds. Okay, I assume that means no questions. If you have any, let me know. I'm always happy to help. For those that reached out to earlier today, if you're a little behind on homework, please try to get caught up soon because 8 weeks goes quickly, and if we start to fall behind, it's hard to catch up. If you have any questions, let me know. I'm always happy to help. We can jump on a Zoom call and work through things. You don't have to wait for class. For the next hour and 15 minutes, I'm just going to be sitting around waiting for questions to come my way, unless everybody leaves, which I think is going to happen because everybody in fashion is already packing up, waiting on me to finish up. If everybody leaves, I might go back to my show. But for the next hour until 9:50, I'm gonna be sitting around waiting for questions. But send me a question anytime. I'm like a 5-hour meeting tomorrow. But other than that, my weekend is completely open and we can just hop on the Zoom call and work through homework and stuff like that. And make sure everybody's caught up before it gets too late.
Question, will you be here Monday?
Monday I'll be here. The schedule on my door will be next week. See you next Tuesday. Let me know if you need any help with anything. So again,